Thank you for the audio, Karan. Let's start. So, hi to everyone joining us today. It's wonderful to see you all here. Let me introduce myself. My name is Ayushi, and I'm working as operations specialist at Udacity. In my role at Udacity, I oversee multiple initiatives and manage day-to-day tasks under the School of Programming and AI. So I have more than 5 years of experience in the edtech sector, and it's truly my honor to contribute to the growth and success of learners here at Udacity. We have started this initiative, and let me share the details about the initiative here. These webinars are designed to deliver value that goes beyond the core curriculum, offering you opportunities to explore impactful advancements shaping industries and careers. Through these webinars, you'll gain actionable insights, advanced skills, and the inspiration to stay ahead in your field, all guided by the exceptional expertise of our mentors. I'm delighted to introduce my co host, Karan Wazirani. He's a vital member to our internal team. He oversees operations for the School of Business, where he ensures a smooth and enriching experience for both learners and students and mentors throughout their journey. Thank you, Karan, for being here. It's my distinct honor to introduce our today's speaker, Ram Kumar. He is an alumnus of world renowned IIT Madras and has successfully established his own AI startup. Not only this, he has been a dedicated mentor at Udacity since 2019, guiding countless students in the School of AI and Data through various nanodegree programs that he graduated from. We are truly privileged to have him share his wealth of knowledge and experience with us through this webinar. Before I hand it over to Ram, please note that this session will be recorded, and all of you who are joining, you must put the Q&A, use the Q&A tab to post your questions, as we will not be taking up the questions from the chat box. So, without further ado, I'll hand it over to Ram.
Thank you, Aishi. Let me share the screen. Hope it is visible to all.
Yes.
Yeah, so today we are going to take a session on how LLM can be powered with knowledge graph. So knowledge graph is been there for quite a long time, but integrating it with LLM can give a power to LLM to make it to give more precise response. Okay. My name is Ram. I'm a co-founder of organization called Tensor Learners. It's a small startup, and we are into AI consulting. And I have around 16 years of experience in data science, AI, and also in supply chain optimization. So I have worked in companies such as ABN Bev and Infosys for a long time in the area of data science and analytics. And I'm associated with Udacity for around 5 years in terms of mentoring and other activities as part of this organization. So today topic we are going to see how I mean what is the challenges of LLM? LLM being a powerful technology still has some of the challenges which can break some of the uh, industries. Okay, so they may not be useful for some of the industries. We will see what are these challenges, and we would also see how the knowledge graph can be a ideal solution to mitigate these challenges. So we would see how we can integrate a knowledge graph with LLM with a case study. So this case study is a miniature of a real situation case study. We would see that how we can integrate knowledge graph with LLM and how it can give us a more precise response. And also these knowledge graphs with LLM has some challenges and what are the future innovations that is taking place in this area. So you see this LLM is a very powerful technology that is powering the many of the AI-driven processes in the industries as of now. Why? Because it has been trained in a very large data set that is never seen before. So basically what is powering is the architecture of the LLM. So LLMs are being done using an architecture called transformers. So transformers systematically changes the way the model is being trained. So previously, the language models were built using RNNs, I mean recurrent recurrent neural networks which are sequential in nature. So this sequential nature makes the training of the language models a bit difficult and time consuming, and also resource drain, because it is not a parallel in nature. Since it's sequential in nature, the GPU cannot be used extensively. So, but this transformer architecture changed this completely, and here it enabled the parallel training of it. So we can use GPU to train a very large volumes of the data. That is the one thing. Other thing is that the important thing is the self-attention mechanism. So here you are focusing on a certain word in the context of a sentence. Okay, so this actually makes it more precise in terms of identifying what should be the next letter. So these two innovations actually makes this large LLM, large language models, more powerful. So that is the innovation, and OpenAI has made this drastic change into this industry, and they brought in the GPT three onwards these architectures, and they are powering most of the AI-driven processes right now. And not only that, so they have the option to get fine-tuned with industry-oriented data. So we can take a GPT architecture, we can modify or train it, fine-tune it with our own architecture and make it deployable to our own specific industry. So that also makes this LLM more powerful. And the human-like response actually sunsetted many technologies. So if you see 3 to 4 years before, there were chatbots which are like intent-oriented, rule-based chatbots. Now those technologies has been sunset. Now we can bring in LLM as a chatbot, which can give you more like a human-like response and more precise responses. We don't have to configure all those interns and manual rules. Okay, so this has sunsetted many technologies. That is the power of LLM. However, these LLMs has challenges. Okay, so this one of the major challenge is the hallucination. So this is a very unique challenge. Okay, so in traditional ML models, you have a lot of metrics that can capture the errors. Okay, like what do you say, accuracy, precision, recall, etc. Whereas hallucination is a different challenge. Here, the LLM can respond in a way that looks like a factual response. However, if you dig deep, there may be a slight flaw which is not visible to our eyes, like statistical issues, like factual issues, like interpretation issues, and many things. So these are called as hallucination. It builds up its own response with pre-trained data. Okay, so that is a huge issue that is facing, and it can make LLM not usable in some of the industries. For instance, like healthcare or finance sectors, where you need a more precise response, right? So if there is a small issue, a small factual error in a healthcare, it can cost a lot for the country as well as the healthcare sector. So these kind of industries are still apprehensive to use LLM for some of the critical processes. So, and also another issue, the fallout of this issue is that interpretability. So if LLM has given a response, it is very difficult for you to go back and see how this response has came from. So for instance, like you have a, it is been trained on a very large volumes of the data, right? So you cannot actually go back and investigate where it is coming from. And there are minimal implementation of other libraries that can help us to interpret the LLMs. So there are limitations in this kind of interpretations. So these two are some of the challenges of the current LLMs, and we have also seen there are real world examples of these LLM issues. For instance, many advanced models like GPT-4, Mistral 7Bs, etc., have provided errors in providing medical information. So they are tested as a POCs, and they have found to provide some factual issues. And also in industries like legal, research-oriented innovations, LLMs tend to provide their own kind of interpretations which are not actually usable in the industry, in the actual process. So these issues makes the LLM not usable in these kind of industries like healthcare, finance, legal sector, etc. And these are some of the examples, okay, but many examples are there, and the industry experts are actually finding it difficult to use these LLM in these industries. Okay. And as I said before, LLMs has inconsistent, I mean, factual issues because they are trained on a huge volumes of data and it is dated. So if you see GPT-4 or any other model, it will be dated like September 2024 or very recently like December 2024. But after that, what is happening? Okay, so the real-time data is not there in LLM. So for that, we need to create a RAG kind of an architecture, which is retrieval augmented generation. Even with retrieval augmented generation, there are issues. For instance, in the RAG architecture, as of now, most of the applications are using vector databases. Okay, so vector databases has its own limitations in terms of retrieving the results. For instance, vector database breaks the data into chunks. For instance, let me show a document. So if this is the research document, you can see large volumes of data, right? So there are a lot of data here. However, these vector databases break them into chunks of data and then store it in the indexes. So what happens if there is a sentence here and whereas this sentence is related to something that is written here? So this contextual linkage is not there in the vector databases. No matter how much retrieval mechanism you employ, there is a limitation of the vector databases. So this connection is what is not there in the current track. So let me go back to the slides. So this inconsistent retrieval can provide us a lot of factual issues as well. So this is one of the main reason for so current RAG architecture not suitable for the LLM application in these industries. Other than that, how do you feed the real-time data? How do you refresh the real-time data? Let's say you are connecting an API. In what format it has to be saved? Even though you are providing a real-time API, the format in which it is saved or stored will be a challenge for the LLM to process. So these are the challenges, these are the gaps that we can find in the current architecture. And in coming down, we will see how the knowledge graph map all these information as a relationship so that it improves the way the LLM can understand the information. Okay, so before going to the next chapters, we will have interactive quizzes. So let me start the poll here. So first one is on the basics of the LLM. What is the main reason why large language models can produce hallucination? Let me start the quiz. So I will give you 30 seconds. You can look into these options and provide the vote. So what is it a lack of retrieval mechanism? It's a reliance on supervised model, or there is a computational issue. So what could be the major issue that drive it to the hallucinations? Let me give some more time here. Yeah. So think about how the datas are retrieved. So that is one of the major mechanism for to avoid hallucinations. So we got many votes, and I would publish share the results. So it's correct. Most of you have selected the correct response. It's a lack of access to the retrieval mechanism for external data. So how do you access and retrieve them? And the second most response is over reliance on supervised learning, whereas it is not the case because this is a generative based model. There is no over reliance. The GPU and other issues are already taken care of. Only thing that LLM lacks is the access to the external data, how it retrieves. Even if external data is provided, there should be a correct mechanism to retrieve it. Let me go to the second poll, which is what challenges does um, the black box nature of LLM pose? Okay, so this I have covered in the recent slides. So think about the response. I will initiate the poll again. So is it a limitation in process of large data, or it makes the prediction less reliable? It reduces the interpretability and traceability, or it slow down the training time. So what could be the response for this? Think about the large nature of the LLM. Is it possible for us to dissect it and see where the issues has happened? That if you think about that, then you can easily answer this question. Yeah, so let me stop here. So yes, so most of you has responded correctly, and it is reduces the interpretability. So it's more like a black box. It's very difficult for you to understand where what data has made the LLM to give this response. Okay, so the fallout of that is making the prediction less reliable. The actual issue is that it is reduces interpretability and traceability of the outputs. Moving on. So how we can solve this? The knowledge graph. Knowledge graph is one of the recent technologies that can be integrated with LLM that can actually reduces the hallucination. Why? Because the structural nature of the graph representation. So if you see this knowledge graph, it follows the graph theory. So what you have in the graph theory. So here you can see the nodes. These circles are the nodes. They are the entities. Okay. So all these entities are connected with each other through a relationship. Okay. If you establish this relationship, then you can easily see any node can be connected to any node through different relationships. So this makes the what is the traceability of the data very easy. And also, if you see each one of them, they also has a property. Let me go to the actual knowledge graph here. So here you can see Neo4j is one of the top player in providing a knowledge graph. Their product is well suited for LLM integration. Some of the competitors include Tiger Graph, but Neo4j has the largest market share. You can also open a free instance. Okay, so you can go and log in with your email, and then you can open a free instance, and you can they will provide you with all the credentials, and you can start running and experimenting. So here, this is an example knowledge graph. See here, it's nothing but people purchasing mobile phones and how they are related. So there are different categories here. So here you can see the category which is a smartphone or accessories. Okay. So accessories, there are not much other nodes, so it is lying as a standalone node. Whereas here, smartphone is connected to the other nodes. This pink color is the actual mobiles, iPhone, Samsung, Google Pixel, etc. And the users, you can see Alice, Bob. These are the users who have bought or viewed the product, and you have the brands, so Apple, Samsung, etc. So you can see all these node are interconnected, and you can see the relationship how they are interconnected. And also, if you click one of them, you can see the properties. Here, the name is the property. In addition to the name, you can also provide the cost of the product, any other information, the color of the product, etc. So in that way, you can easily configure the data. If you see the actual code, this is the code here. So here the product is the node, the product one. What is the product? It's a iPhone 14. What is the property? Its price is 999. So in that way, you can provide the information. You can see how they are connected, interconnected. So this makes this a more powerful structured data compared to a relational databases. That's actually makes this knowledge graph a very important resource for a LLM. Okay, so you can see, so these are the main things: entities, the relationship, how they are related, and what are the properties and attributes of each entities. So if you are able to provide this information, we can easily create a knowledge graph, and this knowledge graph information can go into the LLM, make it more precise in the response. So what it actually solves. So here you can see. Knowledge graph provide more factual information and in a structured format. So compared to a relational database or something, this structured format is very easy for you to understand. So if you have a table or something, it's very difficult for you to understand how they are related. Whereas this is a pictorial representation of how they are interrelated, and this provides a more easy to understand structural data. And this actually solves many things. So you can provide a real-time data, you can actually compare a statistical information. So this makes it to provide more factual information uh, to your LLM. So we will see that in the case study where I will show you the codes, how providing these kind of factual information make it to give a more precise response. The fallout of it, the what do you say? Because of this, we are eliminating hallucinations. Obviously, if you provide a more precise data, then it can easily eliminate hallucination. Like LLM by itself does not have a property to eliminate hallucinations. No matter how many times you query the LLM, telling that this is the wrong answer, you provide more examples or with the prompting, etc. Still, there will be a kind of a hallucination quotient within the LLM. Okay, so to reduce that, we need to give in an injection of the data as structural data and tell that this is the structured data. Don't go beyond that. That is the prompt engineering part. Compare in combined with the knowledge graph data, we can easily reduce the hallucination within the LLMs. So, so this is a hybrid RAG system. So what we normally see in the RAG, let me so if you see this, this is the normal RAG, which is like 90 percentage of the applications that is across the globe. So many companies have only established this kind of a RAG system where they use the vector databases to provide the context to your LLM. Whereas in hybrid RAG, we are providing it with a more relevant data. So this is the vector databases, which this is the knowledge graph query, and this is an API, real-time data that is going into the process. Okay, so here we are going to see this line. Okay, so how we can connect a knowledge graph into RAG system and how to provide a more precise response for this. So this is the hybrid architecture. Moving on, here what is happening? So we have taken the middle path, I mean the central path, which is the RAG with knowledge graph only. So if you see this, the ultimate goal is to identify the entities. So if you see here, these are the entities, right? So these circles are the entities. So these circles are the entities. So we first thing is to break down the query and to identify the entities. For example, let's say this is how does the quantum computing affects encryption. So there you can clearly see there are two entities. One is quantum computing, another one is encryption. How it is affects. So you can easily understand these are the two entities. Affects is the relationship. So we need to create a kind of a query processing to break down this query and identify the entities and the relationship. Once you identify that, you need to create a cipher query. So cipher query is a native language for a Neo4j. So similar to that, if you use any other product, you can use their own languages. So it's a native query language. It's very similar to not similar in a structural way. It's similar to SQL in terms of querying. Okay. So you need not have to create cipher query every time. Okay, so you can use here you can use an LLM to give you the cipher query. Only thing, you break down the query into nodes and relationship and give that to an LLM and ask it to generate a cipher query. So it will neatly create a cipher query. There may be errors, so you need to create a logic to refine the errors when it creates the cipher query. In the production environment, we can create a logic for that. So these errors can be eliminated and then it gives you the cipher query. This cipher query can be injected into the knowledge graph in real time and fetch the information. So here this is the query. So the name, how it is affected, and based on that, return whatever names and relationship that matches this. Okay, so based on that, we are getting the response, and that response, we are sending this and getting the response. After getting the response, we are feeding it into a LLM, and LLM sees the factual information and gives you the very precise response to you. So this is the workflow overall, and we will go to the codes. Before that, let me have some quizzes. So the third quiz here is, what role do relationship edges play in a knowledge graph? Let me open the polls here. So what do relationship plays in a knowledge graph? Okay, or they store the information, they define the connections between the entities, they act as a placeholders, or they just tokenize. So the answer is very straightforward. Think about the entities and how they are related together. So with that, you can easily get a response. Let me give you 3 more seconds here. Yeah. So yeah, I got most of your responses. So here is perfect. So it is the relationship. It defines the connection between the entities. If you're able to define the connection, it solves the most of the purposes, right? So that's what it's doing, the relationship. Let me go to the next question. How does integrating knowledge graph helps eliminate hallucination? So this we have covered in the recent slide. Or it reducing the amount of training data by using verified structured data, by limiting the LLM to answer only predefined queries, or by replacing the LLM generating. So think about how structured nature of the knowledge graph can help you in LLM. So yes, I got most of the responses here. That's right. So it provides you the most structured and a verified information to the LLM. So it grounds the LLM responses. But this is very important for a real-time scenarios. Okay. So with that, we will go to the case study. So what is the case study here? So we have seen the knowledge graph, right? So we saw the workflow, how it is going to break down. So here I'm providing a more real world use cases. Let's say it's an e-commerce platform. So in an e-commerce platform, there will be a lot of entities. So you have a web pages that some people will come and click the web page. Some people just view the web page, I mean, view the product. They won't buy it. Some people will buy it. So there are a lot of relationship entities are involved. Some people will click it, move it to the cart, and they won't pay it. So there are a lot of entities involved in it. So this is an ideal e-commerce is an ideal case for you to integrate a knowledge graph so that the LLM will give you more precise response. So here, what we are going to do is to create a knowledge graph, and then make as a relationship, and then based on it, a knowledge graph will be created. So once it is constructed, then we can actually break down the queries, the user queries, into entities, and then pass it on to the LLM to give us the cipher query. Okay, so this cipher query can be injected into the Neo4j and fetch the real-time recommendations. Okay, so this will happen fraction of seconds. So once you inject it, immediately you will get the response. And once the response is gathered, we can give it to the LLM, which gives you a more precise recommendations. Okay, so let's go to the code here. So this is a code. Let me zoom in. Yeah. So for this, what you need? No, you need a Neo4j access. As I said before, so Neo4j is this Aura version is free for all. You can create a free instance with your email ID. Once you created it, they will provide you all the credentials, store the credentials. They will give it as a one-time screen. So you need to store that. After storing that, you can actually use it in your code. Okay. So the packages required is Neo4j and OpenAI. So these codes are available here. I have given you the access here. Just going back. So you can use this GitHub. um, to download the codes. Yeah. So these are the packages you need to download. And then after that, we need to create the data source. So for that, we are simulating and creating a kind of a data here, and then using this Cypher queries to inject these and create the nodes and relationship, etc. So this is a very small data set. Okay, so but in a real time, you would have a lot of millions of nodes and etc. So for that, there are automated packages that is available, but here manually we are injecting this code. Okay, so what you need is URL. URI is from your Neo4j. You can get the instance URI from here, and then the username, password, and then the driver. Okay, so you pass it as this code, and then if you execute it, all these Cypher queries will be executed. So what we are creating here is first the users. These are entities, right? So these are entities. Here within this bracket, we are providing the properties. Okay, so you can add any number of properties. Okay, even if you want to add weightages to a particular entity, you can add it. So after that, products, categories, and brand. So all these things you can visualize here. If you want to run a query, also you can run and fetch each of these nodes here. Cipher query, you can run it and fetch it. So the users, the products, categories, and then the brands. Okay. After that, the querying the knowledge graphs. Okay, so what you after this we are running this code driver session and then executing this. After you execute this, all these information will go in a real time and create a knowledge graph there. So once this is done, you can actually test it. So here this is a testing query. So match the user to the product which has certain interactions. So based on this, it will give you the queries. So this will tell you that this knowledge graph has been established, and you can query it using the Cypher query, and then get whatever information is required. So this is just a display of the knowledge graph here. Once that is done, now we are going to simulate it. Okay, so you have the knowledge source. So this is the knowledge source. Now we have to, in a real time, dynamically construct a Cypher query. Okay, so how we can do is we can use an LLM to do it. So this is the LLM part, GPT-4 we are using. So this is the function that is going to provide the prompt to the LLM, and using that we are going to create the Cypher queries dynamically. So we cannot manually create the Cypher queries every time, right? So there may be millions of transactions. So every time a manual engineer cannot write a Cypher query dynamically. So we need to have a kind of a automation mechanism. And again, LLM here can come to our rescue. So we are using GPT-4. We are providing a prompt-based instruction, you are a system, you are a Cypher query expert, you're going to access the Neo4j, and this is the user import. Based on this, construct the Cypher query, right? And you can decide what product similar to the iPhone 14 should I consider. Okay. So this is the thing, and once you pass it on, it understands what are the entities, and based on it, it is going to give you the Cypher query dynamically. So this is the Cypher query that is generated from the LLM. Okay. So it says that the product is iPhone, which is what are the products that are similar to it. So return those similar product names. So this is the Cypher query that LLM has constructed. We have not manually constructed it. Okay. So once you execute this, next phase is the execution phase. So we cannot directly run this Cypher query because you can see a lot of text here, right? So these are from the LLMs. So we need to sanitize it. For that, we can create a regular expression logics that can sanitize it. So you can create a more robust regular expression logics to seeing various cases. If there is an error, how to handle it. So this is a part which we need to construct, because sometimes there may be some kind of additional letter or something which comes along with Cypher query, which prevents it from executing correctly. So you need to make sure we construct it in a more precise way. Okay. So once you have this function ready, we can send that Cypher query response and then extract only the specific these two lines of code. Okay. So after this, we are running it again using the driver sessions. We are executing that Cypher query and fetching the recommendations. So this will go here. This will execute very similar to what you're executing here. So for instance, um, you can try and copy paste here and see. Okay, so here it has responded Samsung Galaxy S32. Okay, so similarly, it's we are going to run it here from the Python codes, and then we are getting the Samsung Galaxy S32. Okay, so we got the precise recommendation. There is no hallucination here. This is what the data tells. Now, once this recommendation is comes, the next step is to package it and give it as a response to the user, right? So again, we can write a a prompt here, a function here. We're telling that this is the recommendation, give a nice response to that. Also, based on the LLM knowledge, it can gives more additional information. That is the domain of LLM. So we don't have to worry about it. So LLM can see the recommended product and give you the more precise respond to it. Okay. So you can use this model GPT-4, and then you can use it to give the four response. So these are the responses, and it has mentioned Samsung Galaxy S32 as a recommended product. So this is a very small example of how a knowledge graph can make the LLM response more precise. And it depends on two factors. One is the data that's coming, the structured data that is coming from the knowledge graph, and also sometime this from the knowledge graph, and also go back to the knowledge graph and then see how it is actually connected. So if this is the knowledge graph, you can easily go and investigate whether this is correct. So Samsung Galaxy 32, it's near to iPhone 4, and there are people who have searched for it. So these are all factual information. There is no fudging of data. So it's all factual information. There is no hallucination. We are preventing the LLM from hallucinating because of the structured nature of the data that we are feeding. Okay. So this is the complete workflow of the case study. In a real time, it will be much larger. So the knowledge graph that you construct needs to grow. Okay, these are some of the challenges we will cover the subsequent slides. So this is the case study that we covered. It has stages. One is data source creation, retrieval of the information knowledge graph, giving it to LLM to give us the specific response. So there will be situations, right? So what to use? Whether should I go with knowledge graph or vector DB? Should we completely replace vector DB with knowledge graph? No, absolutely no. Because databases have their own advantages in terms of scalability. So here, if you see scalability, nobody can beat volumes of data. Though the context is context preservation is less compared to knowledge graph. Wherever the very high volumes is required, we need to go with vector databases or a hybrid databases, right? A hybrid RAG system. So retrieval, it uses similarity metrics, similarity searches to get the relevant data, whereas knowledge graph uses entities relationship to get the data. So retrieval mechanism changes. The context preservation. So how it preserves the context? It preserves using the chunk of data, right? So it breaks the big volumes of the data into chunks and then preserve them. Whereas it gives a more structural integrity of the information. No matter where the data is, it will be related. Okay, so there will be some kind of relationship between different entities. So that is the structural integrity. So you can query or you can trace it to see where the information is coming from. That is a major advantage of the knowledge graph. Okay, so if it is a very complex statistical based queries, obviously knowledge graph is going to be the uh, uh, solution, because knowledge graph has the structural depth. So wherever the precise information is required, complex queries are involved, we need to use knowledge graph. So it depends on the industries as well. So if it is a healthcare or finance industry, chatbot for front-end customers who doesn't look into the factual information. Okay, and if you see this graph, you can see that is kind of a steady they made vector databases as well. Okay, so you can see the performance difference. Most of it, or almost
I
precise,
think, Ram, your
like
voice is a little breaking. Can
attempted document or document questions or a top 100%. That's how. Yeah, can you hear now? Is it clear?
yeah, I think maybe you can try switching off your video and then we can go ahead.
Yeah, just a moment. Yeah.
Yeah, it's good.
So these are the things you need to see, factors you need to see before considering an LLM application. What type of industry, what use cases is trying to solve. These are the important things. And finally, we come to this area. There are obviously challenges, and what are the future directions? So, knowledge graph, though it provides valuable information to LLM, it has its own challenges. How the knowledge graph grows? Is it a static? Okay. Um, so you can see the knowledge graph here. Just give me a moment. So this is the knowledge graph here. So this is a very small miniature version of the knowledge graph. Whereas in the actual industry, of as the data grows, as the e-commerce industry or as the e-commerce platform accumulates more data, this knowledge graph has to grow along with it, right? So this need to be expanding dynamically with the operations. So that by itself is a challenge, because how do you run it? Can we trust an automated platform to create a knowledge graph, or there should be a manual employees? Manual employees cannot scale to this extent. So what is the solution? That is a research area that is going on. So far, these knowledge graph can be used in a smaller use cases. If it is a industry level application, then we need to see the automated capabilities of the knowledge graph. Okay, so so this is another challenge. And how do you construct? How do you maintain the structural truthness of the knowledge graph? So there may be errors. Uh, so providing the entities, there may be an error, factual error. There could be a bias involved, right? So instead of providing Google here, I might wrongly type something. So even the automated core code might have provided some wrong information, and it branches out as a nodes. So this factual error while generating, we need to prevent that. So this is another challenge that is part of knowledge graph integration. So these are some of the challenges, and major players like Neo4j are trying to address these challenges. And there are a lot of innovations that's coming out in parallel to the LLM innovations. So if you see the LLM industries, they are keenly watching the knowledge graph technology. Okay, so we may be only thinking about LLM and RAGs and all those things, but all the industry experts are keenly watching how the knowledge graph is evolving, right? So that is the direction the industry is going in, and we are also trying to that industry is also trying to adopt graph neural networks. So this is mainly used in physics, biology industries, where they predict the next graphical structure of the scientific elements, okay, a biological structure. So that application is that use case is suitable for knowledge graph expansion. So if you are building a huge knowledge graph, if we have a model that predicts what will come next node, what will be the next relationship, that will be an added advantage. It will help us to automate the knowledge graph creation more efficiently, right? So that is some kind of a innovations, experimental areas that is happening. We need to wait and watch how this is evolving. So these are some of the challenges that we face as of now. Okay. So that comes to the end of the session. Yeah, we can go for the questions.
Thank you so much, Ram, for such an engaging session. Now we're opening the floor for Q&A. If you have any questions, kindly post it in the Q&A tab that you can see below. So we have few questions already there for you, Ram. Let's take the first one. Can I find some energy use cases for European Union companies?
Energy use cases, if you see, energy industry is one of the pioneer industry in adopting knowledge graph technology. So if you see the ontologies of energy sector, they have ontology. Ontology is nothing but a structured way of representing the equipments in the energy sector. So if you are constructing a big plant or something, there will be millions, I mean, thousands of equipments that is going into it. How they are related. So there need to be a map. So this ontology structures are available in energy sector. So if this ontology, so knowledge graph can be easily integrated with this ontologies. If you have the structure, we can program it and create a cipher queries so that it branches out like a structured ontologies within the knowledge graph itself. Here, what we see, there is no structure, right? So it just expands and we have relationship, etc. Whereas in ontology, it comes like a top down, where it starts with one element and then branches out into multiple elements and relationship, how this relationship comes into. Everything is a rule based. So energy sector is an area where we can easily implement this knowledge graph and then use for LLM application. There are case studies. Some of the case studies even Neo4j has. We can search in their repo. Whereas if other case studies links are there, we will respond you as a follow-up to this session.
Yeah, I think if you have, if the answer is not still, if the question is still not answered, please feel free to use the Q&A form link that will be shared in the slide deck itself at the end. So we'll go to the next question. Can we use a pre-trained LLM with knowledge graph, or do we need to work from the scratch?
Yeah, we can use a pre-trained LLM. So here, what we are using is out-of-the-box LLM here. So LLMs is just see your real recommendation. So factual information is fetched from the knowledge graph, and we are feeding into an LLM. LLM is like a facilitator. So it sees the factual information, it provides a wrapper around it and gives to you. So you can use out-of-the-box a capable LLM to combine the response from knowledge graph and give it to you.
Amazing. Thank you. Let's go to the next question. Bhanvi says, how can we create a model having both real-time information and also my local phone information so that I can use it to know information easily and access my device files after giving a prompt?
Yeah, so if I understand, you have a local data as well as, and you want to connect it with the real-time data as well, right? So there are multiple options. If you go, let me go back to the hybrid architecture. Yeah. So here you can see this RAG. Actually, RAG is versatile enough for you to connect different sources. So there are packages like LangChain, etc., orchestration engines that actually let you connect with the real-time API. So if you have an API to your real-time data, then you can bring it as a API consumption layer as part of this RAG. That is this line. And if you have your local data, then you can go for two approaches. Either you can fine tune your LLM with your local data. So you can use the LoRa technique to fine tune them for based on your local data, and use the API as a kind of a RAG, and then have this one line with your fine tune model. Either way, you can go. else, if you don't want the fine tuning, you can go with out of the box. Then you can use this line as well as the this line. So you don't need a knowledge graph. If you don't need, you can skip this. So this area will give you the real-time data, whereas this area is the data that you have locally. Combining them, we can give you consolidated response to it. So we can innovate on the architecture to handle your use case.
Amazing. I think that answers her question. The next question is, can knowledge graph add a significant time overhead?
Yes, yes, definitely. So then there are areas where it can add overheads. One is the knowledge graph creation. So here we have created a very small knowledge graph, which is only fraction of seconds. Whereas if it is a millions of rows of data, then how do you structure it? You need to have a strategy to structure it, whether to go for ontologies. So ontologies is nothing but industry standard of how these graphs should be represented. So if there is an ontology for an industry, we can adopt that. If there is no ontologies, then we need to create from the scratch. Okay, so this is a latency. This is the difficult area challenge here, the creation of it. After you creating it, the latency comes with the consumption of it. Okay, so not the consumption, actually how it grows. So if it is a real-time e-commerce platform, there is a transaction happening every time. So how it actually grows. If a new product is coming in, automatically that product node has to be created here in this instance, right? So that kind of a pipeline, the data pipeline challenge will be there. Okay, so these are some of the challenges that can introduce latency to the process. But as I said before, the companies are working extensively to mitigate these challenges. There are automated platforms available to automatically generate that. If a data comes in, you can trigger a lambda or a event that immediately creates a node in your live knowledge graph. Okay? So that can solve the latency.
Okay. So the next question is, can you give us a criteria for determining when to use vector DBs or knowledge graphs?
Yeah, so that is actually covered here in our session. Um, so criteria, one of the major criteria is scalability performance and what type of use case. Okay, so if scalability is not your major concern, okay, so the preciseness of the response. Let's say if you are in a healthcare sector, a healthcare person is evaluating some informations, patient information. That the preciseness of the response is important, not the scalability. So in that case, knowledge graph is your ideal solution. You need to have knowledge graph, okay? Whereas the scalability part is required. There are millions of people. It's an entertainment website, okay? They are just typing in, getting some response, like something like a chat GPT or something. So there you don't need the 100% preciseness, okay? So there, if you want to handle those kind of high volume, you have to go with a single RAG architecture with only vector databases.
Okay, amazing. So the next question is again, if knowledge graph is a known solution for expanding LLMs, then why hasn't it been implemented yet? And how can we implement
Yeah,
it?
yeah. So knowledge graph adoption has recently increased. I think it has started from 1 year before itself. But what stops is these are the challenges. The challenge which I mentioned, the automation, who creates the knowledge graph. So here, if you see here, um, so this is the code we are running, right? So this is manually we have entered it, so there is no error. So if we use a LLM to generate or automate this, or if you have an automation libraries, there may be some errors, right? So who creates this knowledge graph? That is a challenge. How much big a team should be there? So that is a challenge. And other than that, the latency part, still now the knowledge graph industry has improved. Whereas six months before, 7 months before, it was in a pretty nascent stage. Now it has improved. There are a lot of automation platforms. Now the industry is turning towards knowledge graph. Whereas what happened, the industry gone with the hype, right? So industry gone with the Gen AI hype, and many of the project managers, the senior level, pressurize the company to implement some Gen AI applications. They use the vector databases and implemented most of the applications. Now they face the challenges. These vector databases not able to provide more precise information, so they are recalibrating their application. They want to bring in the knowledge graph. Now the focus is on it.
Okay, she has another part of the question which says if you automate the knowledge graph, then the problem of context and backtracking will arise again.
Yes, yes, obviously. So if we automate the creation of knowledge graph, some of the nodes, some of the entities, there can be errors. So if one node gives you an error, then subsequent node will fall into a wrong bucket, right? So that is a challenge again. So how do you mitigate that? Then we need to bring in graph neural network to see if this is the data, this should be your predicted structure. If your created structure matches with your predicted structure, then your knowledge graph is fine. Maybe 5% error is fine. So we can use GNN for it, but that still is a evaluation stage. So yeah, so you're right. The structural integrity error can arise because of it.
Okay, I hope that answers her question. The next thing is, Shaza wants to know if programming is needed to handle LLM. Her background, the learner's background is mostly in electrical engineering.
Programming, I mean, not a very expert in Python. So if you're like a moderate level Python code who can run some function or something, that will be enough for you to run an LLM, because everything is no code platforms are available now in Azure as well as AWS. You can easily call in the LLM models and then connect your RAG. So there are Azure Foundry. If you export that, it has zero codes actually. So you can integrate and run an LLM without typing any single code. So those packages are available. But if you want more customization kind of a thing, knowing a moderate level of Python will be sufficient for you to run LLMs,
Okay,
work on
uh,
LLMs.
amazing. So the next question, I'm not sure if you'll be able to answer it right now. Can you give us any information sources for ontologies structures?
Yes, definitely. As a follow-up, we can give you ontology structures. So the ontologies are there, specifically is there in banking sector, as well as in petroleum, energy sector. These are some of the industries which have ontology structures. Also, I think in biology structures, but we can give you as a follow-up response to that.
So, if you want to get this answered with some link or some sources, please use the Q&A form, fill the Q&A form, and there you can put up this question. We'll answer that. Um, yeah, over there in the slide deck, you can see it's there. The link is there. So the next question is, can we improve the problem of scalability of knowledge graph with a large volume data set by forcing nodes with predetermined ontologies?
Yes, ontologies can help us a lot in terms of structurizing the knowledge graph. So yes, so even Neo4j, you can search for it. So Neo4j is bringing in some of the specific ontologies also. So if ontology is there, the construction of the knowledge graph will be more systematic and will be more easy for even for a automated LLM. So there are, for instance, I think Lang graph or something. It provides an automated way to create knowledge graphs. So this ontologies can help it. So yes.
Okay. Um, okay. So the next question is cipher query generation, a specialized. Okay, I think they're defining it. How does the automatic packages work and capture the data in the format required for the knowledge graph?
So how it works is, so let's say you providing, let me go to a document. Uh, just give me 1 minute. Yeah. So let's say this is your corpus document, okay, and if you provide it to your automated packages, so graph creation packages, what it does is that it breaks down this entire corpus into entities. Okay, so it runs through the entire document corpus and then creates the entities. You see that how they are related. So it captures the relationship and the properties, everything. So it lists down everything, and it lists down what are the entities and what are the relationship and what are the properties for each entities. Once that has been captured, then it will try to map each of the entities with the relationship and provide the properties into it. So all these things are automated. It's a kind of a machine learning kind of a internal algorithm which runs. It has an NLP kind of an algorithm which scans through and then break down and then integrate and give it as a knowledge graph structure. Once this knowledge graph structure is there, then you can create a cipher query. For that, you can use an LLM for this. So if you tell the LLM that these are the nodes, these are the relationship, and these are the properties, it will gives you a cipher query, extensive cipher queries. Then you can run it and then populate your knowledge graphs. That's how it works. It has two stages. One is to break down this, gather all the entities, relationship, and everything, and then pass it on to the automated cipher query creation, and then you run it. So that's how it works.
Thank you so much, Ram. I think we've covered almost all the questions. And if still there is something that comes to your mind later on, you are free to you feel free to reach out to us via the Google form that we have shared at the end of the slide deck, and we'll try our best to provide the answers.
Um, Ayushi, there are like two or three questions I think that got left. If you don't mind, can we cover them as well?
Yeah, sure, sure.
Okay. Ram, I'll read them out. Um, the first one that I think we missed was, as we know that vector embedding process creates vector values which define closeness of similar properties of words. Is the
Yeah.
relationship created in knowledge graphs different than the vector values?
So the way it works is a bit different. Maybe the automated knowledge graph creation, the packages will use similar kind of thing to identify what are similar, but it actually captures the entities. It break down the sentence. It take the entities. It's I need to explore and then respond to that question. So it's a very good question on this how it works internally. So it can be like a follow up to that question.
All right. Then we'd encourage you to please post the question in the link that's on screen right now. You'll find it in the presentation, and we'll follow up to this. Uh, One other technical question is how does the automatic packages work and capture the data in the format required for the knowledge graph?
I think we have answered this
Yeah.
in the previous question
Okay.
itself. Yeah.
Got it. There is one other question that I wanted to pick up from chat that came in very early. So it says, are you going to deliver a course or a session on how to develop specific RAG plus knowledge graph applications and on fine-tuning LLMs? I can take that since it's a course or a session question. Uh, the next few sessions we've planned, we don't have this specific topic covered, but we'll note it down as feedback, and we'll try and work on something that covers this and showcases specific applications. So I hope that answers your questions, Antia. I think Ayushi, that was about it.
Okay,
Cool.
amazing, amazing. Thank you so much, everyone. And before we wrap up, let me share the details about our next upcoming session, which will be held on 11th of February, where our expert mentor will cover the techniques of interactive data visualization. So do register yourself to attend the session. Before you go, we'd love to hear your feedback for today's session. So once you exit, you'll see a pop-up will come to your browser, which will be about a feedback for us. Please feel free to give us. Thank you so much for being part of this session and see you until next time.